In this video, we're going to talk about rate of change. This is my second video over this, and I think this one is a lot better, so I will probably delete the first video. Just as a reminder, this is page 46 in our binders. This is front and back, so we're going to go ahead and label that F for front. Rate of change, that definition is not going to change. We're still going to say that rate of change is just slope with units, which just means we're using words. We're adding context to this. Let's see if that like this helps or not. A little bit. Okay. Here I've got a graph, and I want to find the rate of change. Remember, rate of change is just another way we say slope. So I want to find the slope of this graph. We're going to take a very new first step. Our very new first step is going to be to write the word scale as big as possible. And we're going to search for an up and down scale, or a rise on our y-axis, and a vertical or a horizontal scale for the x-axis. So I need a vertical scale and I need a horizontal scale. I don't think I like that. There we go. Okay. The vertical scale is going up and down. Scale, remember, we defined that a little bit ago when we talked about the coordinate plane. And the scale told us the value of each line on a graph. Well, going up, one line is worth 1. So the scale on my vertical line, or on my y-axis, is 1. Going side to side, the first line, going side to side, the first line is 1. So the scale on my x-axis is also 1. This is what we're used to. We are used to finding the rate of change, or slope, or constant, while we have a scale of 1 on both axes. Now that we've written the scale and found the scale, we're going to use our normal slope from a graph strategy, positive or negative, rise over run. I tried to write rate. Rise over run. Okay, pencils pointing to the right, put it on the slant, and my pencil points up. So this is a positive line. My rise, I need 2 perfect points. There's a target point there. That's another target point. That's another target point. And this is another target point. And it doesn't matter which 2 we use, because we know that any 2 points that lie on the same line have the same slope. I'm going to use this one and this one. Now our rise is 1. And what we're going to do from now on is, sometimes we might not have a scale of 1, so we're going to have to multiply by whatever our scale is. In this case, our vertical scale is 1. I'm using my vertical scale because the rise goes up and down like our vertical lines do. Over the run is 1, 2, 3. But I'm going to multiply that by the scale of my horizontal axis, because the run goes side to side just like my horizontal axis. So I'm going to multiply that by 1. This isn't going to change anything in this example, since we're used to having a scale of 1. That's because we're multiplying the top and the bottom by 1. 1 times 1 is 1, 3 times 1 is 3, so our slope is still positive 1 over 3. This is the portion where rate of change really comes in handy. This is where we have our units. Look at the y-axis, and the y-axis says number of teachers. So anything on this axis is talking about the number of teachers. This 1 means 1 teacher. This 10 means 10 teachers. We have a 1 as the rise, so that came from the y-axis, so this is 1 teacher. for every, the 3 is the bottom number, and we get that from the run, which is going along the x-axis, which represents the number of students. So this 1 represents the number of students, and this 10 represents 10 students. So when we have a run of 3, this is talking about 3 students. Which means this rate of change, 1/3, really means 1 teacher for every 3 students. And in class, we actually skipped this last question. I'm going to skip that. We're going to take a look at the second example. The very first thing we're going to do, we want to find the rate of change of the graph. That's just the slope. The very first new step is to write the word scale. And we need a vertical scale. Our vertical scale, the very first line says 20. We need a horizontal scale. And on the x-axis, our very first line says 5. Now that I have my scale, I'm ready to use positive or negative rise over run. Pencil's pointing to the right. Put your pencil on the slant, and the pencil's pointing down, so this is a negative. Now I need 2 perfect points to find rise and run. So I'm going to label all of the target points or the perfect points, whatever you would like to call those. I'm going to use this one and this one. I can use these 2 points to get the same slope as if I had used those 2 points, or these 2 points, or these 2 points even, because all 4 of these points are on the same line, so no matter which 2 points I'm using, the slope will be the same. So you get to just pick any 2 points that you'd like. Now my rise is 2 spaces, but each space is actually worth 20. So this is really 2 20s, which means multiplying. We have 2 times 20 to represent 2 20s. Over a run of 1, 2, 3, 4, 5, 6. But this is really 6 5s, so I have to multiply that by 5. Now 2 times 20 is 40, 6 times 5 is 30. When you reduce this fraction, you get 4/3. These are both divisible by 10. So our slope is negative 4/3. The next question asks, what does this mean? Negative means that my temperature is dropping. So we're dropping. We're going to look at our rise first. 4, and rise goes on this axis, which is measuring the temperature in degrees Fahrenheit. So we're dropping 4 degrees Fahrenheit in 3. 3 is on this axis. 3 is being measured in minutes. So the rate of change negative 4/3 means we are dropping 4 degrees in 3 minutes. And we're going to skip this question. The next portion of our notes, this is just a review that I wanted to remind you guys about. We're going to order some slopes, and the 2 terrible things that we do when we order slopes are we ignore the sign, and we also turn slopes into decimals. These are awful habits, but when we compare slopes, this is what we do. Negative 2/3 as a decimal is 0.6666, and that goes on forever. I'm going to ignore the negative sign. 5/3 as a decimal is 1.6, and that 6 goes on forever. Another way to write that is 0.6 with a hat over it, a repeating bar. 3/5 as a decimal is 0.6. And 1/4 as a decimal is 0.25. Steep means it's got a big absolute value, which is why we ignore the sign because we're using the absolute value. And flat means we have a small absolute value. So I need my biggest number here. This really starts with a 0. That starts with a 1. That starts with a 0. And this starts with a 0 as well. Which means this is my biggest slope. Or my steepest slope, sorry. It's the biggest absolute value, so my slope here is the steepest. Next, 2 is less than 6. So I'm comparing my two things that have 0.6's. Those were the same, the first decimal place. So now we're going to look at the second decimal place. That's a 6. And that's nothing, so I can add a 0. Well, 6 is bigger. So the next biggest slope would be G. Then J. And then K. Now we're going to turn our pages over to 47F. Or sorry, this is 47 on the back, so this is 47B. On this first graph, we're going to find the rate of change, which remember just means slope. And our new first step is to write the word scale, and we have to find a horizontal scale and a vertical scale. The scale is just the value of every line, so you look at the first line. This first line on my vertical axis is 40. So the vertical scale is 40. Now I look at my horizontal scale. The first line doesn't have a number. So to figure out that number, I need to first find the first number I see after 0, that is. The first number I see after 0 is 2. So I'm going to circle every piece up until 2. Now I have 2 being split into 2 equal parts. So I'm going to divide that into 2. So 2 divided by 2 is 1, meaning my horizontal scale is 1. Now I'm ready to use positive or negative rise over run. Pencil's pointing to the right. Pencil goes on the slant. We're pointing up, so our slope is positive. To find rise and run, I need 2 perfect points. I'm going to label all of the perfect points on this line, and I'm going to pick to use this one and this one. My rise is 2 spaces, but that really means 2 40s. So the rise is 2 times 40. Now I can count my run. The run is 1, 2. But that really means 2 1s, so I'm going to multiply that by 1. The numerator is 2 times 40. Which is 80. The denominator is 2 times 1, which is 2. And 80 divided by 2 is 40. So our rate of change is positive 40. What does that mean? 40 is the same, remember, as 40 over 1. The denominator in a whole number is 1. So when I look at the number 40, that's on top, which is my rise, which comes from the y-axis. That's 40 sit-ups. 40 sit-ups. I put the denominator there so I'd have something to look at for the run. The run is 1. Run comes from the x-axis, which is being labeled in minutes. So this is 40 sit-ups every 1 minute. Typically, people don't say every 1 minute, which is why we don't typically have the 1 as the denominator in our whole numbers. And we're going to skip that third question. Now looking at a cell phone plan. I want to find the rate of change, which just means slope. My first step when finding the slope is now to write the word scale in really big letters. And we'll have a vertical scale. So we look at the first line, and our vertical scale is 20. Then we need a horizontal scale. So look at the first line on the sideways number line. And the first number there is 4. So my sideways scale is 4. Now I'm ready to use positive or negative, rise over run. Pencils pointed to the right. Pencils on the slant. And the pencil points down, so this is a negative slope. I need 2 perfect points, 2 target points, 2 crosshairs. Those are all of my target points. I'm going to use this one and this one. I've drawn the right triangle. The rise, how far up and down the triangle goes, which is 1 space. So my rise is 1, but that really means 120. So I have to multiply that by 20. My run is 1, 2, but that means 2 4s, so I'm going to multiply that by 4. Now my numerator is 1 times 20, which is 20. My denominator is 2 times 4, which is 8. Reducing 20 over 8, we get 5 over 2. If you divide the top by 4 and the bottom by 4, you get 5 over 2. And we said this was negative, so that's negative 5 over 2. Now what does this mean? Negative means something is going down. What's going down is our number of minutes. So we're losing or we're using 5 minutes. I got that from my up and down axis because that's the rise. 5 is rise. We're using 5 minutes every 2. 2 is your run, and that comes from the x-axis, which is the number of days in the month. So we're using 5 minutes every 2 days. This is probably back in the day when you had to pay for cell phone plans. You had to pay for the minutes that you used when you were talking on the cell phone. Okay, and our last graph to look at today, I want to find the rate of change, which really just means slope. My new first step is to write the word scale, which means I need a vertical scale. Look at the very first line to find the scale. There's not a number there, so we're going to find our very first number after 0, which is 120. 120 is being divided into 2 spaces. So to find our scale, we'll have 120 divided by 2, which is 60. Our vertical scale then is 60. Our horizontal scale, here's my horizontal line, there's the first line, there's not a number there. So I start at 0 and I go until I see a number. my first number after 0 is 3. 3 is being split into 1, 2 spaces. So 3 divided by 2, which is equal to 1.5. That means my horizontal scale is 1.5. Now I'm ready to use rise over run. So I have positive or negative, rise over run. I need to find some perfect points. There's one on the origin. There's a perfect point at 6, that would be 180, because we're adding 60 there. 120 plus 60 more gets us at 180. Then I have another perfect point at 12, 360. 12, 360. I think those are all the perfect points we have on this graph right now. I'm going to use these points here. My rise is 1, 2, 3 spaces. I multiply that by my scale of 60 because that's the scale for my rise. The run is 1, 2, 3, 4. And I need to multiply that by the horizontal scale because that's how we run horizontally of 1.5. Well, 3 times 60 is 180. 4 times 1.5 is 6. And 180 divided by 6 is 30. I forgot to pick a sign. Pencil's pointing to the right on the slant. Pencil points up, so our slope is positive 30. Now what does that mean? Remember, in a whole number, our denominator is 1, and I want a denominator, that way I know how many hours that I'm using. So this is positive, so we're filling up, or we're getting 30 gallons. I might say filling 30 gallons. 30 is in the numerator, which is the rise, which is up and down, and that unit is gallons. Every 1 is the run, which is going horizontally, which is being represented in hours. So this is every 1 hour, or 30 gallons per hour. I hope this was a little easier to comprehend and understand. If you still have questions about this, please message me on Schoology or drop a comment on this video, and I will get back to you as soon as I can.